Hello and welcome to another math video. Today we are looking at finishing up our 6.5 to 6.8 Algebra 2 practice test, starting with number 14. So we've got our model here, which says that the time t in seconds for the pendulum to complete a cycle is equal to 0.2 times the square root of L, where L is the length of the pendulum in centimeters. They want us, first of all, to find the inverse of the function. Now, I kind of disagree with the use of the word inverse there. We really don't invert it. We just solve it for L. And then they want us to use that newly solved formula to find the length of the pendulum if a full cycle takes 2 seconds. One thing I would do right away with this equation or formula is to change the 0.2 to 1/5, and forgive my T there, it looks a little funny. That's just going to be a lot easier, and I'm going to do a little cursive L there. A lot easier to deal with that 1/5 than the 0.2. Again, we want to get the L by itself. The L is being square rooted and being multiplied by 1/5, so we take care of those in reverse order, really. Multiplying both sides by 5 gives us 5t equals the square root of L. And then we can square both sides, so we're squaring the entire 5t, and that gets rid of the square root on the L as well. And then we could finish that up as just 25t squared. And so then the question becomes, if full cycle takes 2 seconds, then we plug a 2 in for t, so L equals 25 times 2 squared. So really, 2 squared is 4 times 25. We're talking 100 centimeters for the length of that pendulum. 15 and 16, we're going to rewrite those to make it easy to graph using transformations. I'm going to zoom in here. The way we have these set up, they're all set up to work out pretty much perfectly. In this case, we can factor a 16 out of this, and I do think this is one I did mess up on my key that I had, so I'm going to make sure I fix that as well. So if this looks different than that, then this is why, because this is right and that's wrong. We take the 16 out of there. 16 times 5 is 80. And the reason we do that is because then we can square root the 16, again, because we can square root this if this is a product. We can square root either one of those. Of course, this doesn't square it nicely, so we don't do that. But the square root of 16 is 4. So we get 4, and then the square root of x plus 5 minus 1. Now that's going to be easy to graph using transformations. We can see a is 4, h is -5, and k is -1, so we can graph that with our transformations. 16, same sort of thing. Little different with the cube root than the values that we're using are a little different. In this case, we've got that 3 out front as well. Again, like all of these that we have, they're set up to work out perfectly. So we factor out that 216. In this case, it just leaves us behind an x plus a 2. Cube root of 216 is 6. So that 6 comes out. Now you could skip this step if you like, and you might jump right to saying, well, 3 times the 6 would be 18. So you could figure that out right away. But y equals 18 times the cube root of x plus 2. Again, we can see there a is 18, h is -2, k is 0, so we could graph that using our transformations. 17 and 18, we're graphing square root functions and finding the domain and the range. See if I can get my screen where I want it to be here. You got the domain and range there at the bottom. I want a little more room there. Okay. So in this case, what we would really be looking at is our x values and then really negative square root of x. And our basic x values are 0, 1, 4, and 9. And if you have to do x and just a square root of x to get started, that's fine. I'm going to jump right to the negative square root of x. So what we do is we do the square root of 0 multiplied by -1, square root of 1 multiplied by -1, and so on. Of course, the square root of 0 is 0. It's still the same when you multiply by -1. Square root of 1 is 1, and then multiply by -1, we get -1. Square root of 4 is 2, so we get -2, and square root of 9 is 3, so we get -3. Now, the h value is a negative 2, k is 0. Remember, h is the opposite of what it looks like. So I'm going to go ahead and x in these original points. So 0, 0, 1, negative 1, 4, negative 2, and 9, negative 3. So where those are going to get shifted left 2, so each of those moves left 2, and they end up here. And I'm going to switch colors yet again to draw the curve through those points. Remember, arrow on this end, and this end over here is an end point. The domain x is always greater than or equal to h, which in this case is negative 2. You should also be able to tell from the graph. It doesn't go past negative 2 for x values. And then the range y is less than or equal to, because of the inversion, okay, or reflection over the x-axis because of the negative there. Y is always less than or equal to, in this case, k, unless it's greater than or equal to k, but it's always in reference to k. So x is greater than or equal to negative 2, y is less than or equal to 0 for the domain and range there. 18, same sort of thing, but we've got kind of a full complement of a, h, and k. Again, my table would actually be 3 square roots of x with 0, 1, 4, and 9 again. So we square root the x, and then we multiply by 3. Of course, 0 times 0, or 0 times 3 is still 0. 1 times 3 is 3. 2 times 3 is 6. And 3 times 3 is 9. H is a positive 3. K is a negative 5. So that's actually going to move those points right 3 down 5. I will X those in. So we got 0, 0. 1 is 3. 4 is 6. And 9 is 9. And then moving those right 3 down 5. So that's actually going to move that 9 off of the grid. And so we get here, here, here. And then this one right 3 down 5 ends up over here somewhere off of the grid. One thing you can do is to, let's see, that's up at 9, so 4 would be somewhere over here. So I certainly shouldn't get up to 4 before I'm off the graph here. So if I draw my curve through there, forgive the crudity there, it's a little tough to graph on this thing. So it looks something like that. Like I said, not my best curve ever. X is greater than or equal to 3 for the domain. Again, always x is greater than or equal to h when it fits this pattern. And the range y is greater than or equal to k, which is our negative 5 for this one. That brings us to our last couple of questions. We're going to be graphing some cube root functions. Their domains and ranges are always all real numbers. So if you want to start with that, you could. Just don't forget to put something there. Our table is a little bit different. And again, I'm going to jump right to the negative cube root of x. So we use negative 8, negative 1, 0, 1, and 8 as our basic points. Cube root of negative 8 is negative 2, but then we've got the opposite of that, so it's a positive 2. We get a positive 1, 0, negative 1, negative 2. H is a positive 3. So I'll X those points in, so negative 8, 2, negative 1, 1, 0, 0, 1, 1. Notice those are always on a line. 8, negative 2. So those are going to get moved right 3. So that is actually going to pull this one again off the grid. It's going to be somewhere around there. The curve can be a little tricky to do, so we'll see how well I do here with the electronic device here for my graph. Not always the easiest thing to do here. Kind of came in a little bit high there, and then curving through here. And so it looks something like that. Not my best work, but hopefully you get the basic idea for that one. The thing that people tend to struggle with is the middle right here, kind of doing some extra unnecessary turns. All right, let's move on to number 20. Oh, I don't even have a stretch or compression here. So it's just going to be x and the cube root of x. Get rid of a little bit of this here. There we go. So just cube rooting the x because a is 1. So cube root of -8 is -2. -1, 0, 1, and 2. H is a -4. K is a +2. Again, remember, domain and range are all real numbers. Don't forget to put that in there. So let's see, let me X in those original points. So -8, -2, -1, -1, 0, 0, and 1, 1, and then 8, 2. So those are going to be moved left 4 up 2 based on the value of H and K. Let's see, that's going to pull this point off of the graph. It'll be a little bit to the left and then up. So just as a little bit of a guide, that'll be about there. Let's see. This is that middle point. Those other two right around it are there. And then left 4 up 2 from there as well. Okay. Again, let's see. Let me pull this a little bit that way. So again, arrows on both ends come through this point, turn up, turn right, and fairly flat as we go through that point there. So again, not my best work ever, but hopefully you get the idea on the basic shape for that. As always, thank you very much for watching, and hopefully you found this to be helpful.